going to go through this question in two different ways. There is a third way that the extended solutions go through. I think it's unnecessarily complicated personally, but have a look at it if you're interested. I'm going to go through it. First of all, the way that the just normal solutions go through it. It's quite a nice solution using similar triangles. And then maybe a less intuitive method that I have used, but I think it's pretty good. And I think it's probably the easiest to understand, but maybe the less obvious one to think about. Because the thing that maybe jumps out, I say maybe, because it might not, is that there are similar triangles in this question. In fact, this one on the left and this one on the right are similar triangles. These two angles are vertically opposite, and then we have alternate angles. So this is the same as this. In fact, they're going to be 45 degrees, and then this angle is the same as this angle. Now, another crucial piece of information is that it says a diagram shows a square, a diagonal, and a line joining a vertex to the midpoint of a side. So actually, this length, if I call it, say, 2L, is going to be twice this length that's L, okay, because this is the midpoint. So the red triangle sides are twice as much as the blue triangle sides. The length scale factor is 2. And that means the area scale factor is 2 squared, or 4. The area of the red triangle is going to be 4 times the area of the blue triangle. So if I say that the area of the blue triangle is capital A, then the area of the red triangle is going to be 4 times capital A. Okay, and we're on our way to being able to work out the ratio of area P to Q, because I can now do one other thing, and that is I'm going to think about the green triangle. Okay, and for this one, I'm not gonna work out the areas, but I'm gonna focus. Sorry, I'm gonna work out the areas, but I'm gonna focus on I'm gonna say that this is the base. I think this is quite a tricky bit, really. This is the base of the red triangle, and then this here. Do you know what? I'm gonna do the colors. So this is the base of the red triangle, and I'm gonna have some height. And this is the base of the green triangle, and I'm actually going to have the same perpendicular height. And I can use this because, so the red triangle essentially has the same perpendicular height as the green triangle, but its base is twice as big as the green triangle. And I know this because of the similar triangle aspect. We already said that the length scale factor was 2. And the upshot is that this is going to have an area of 2A. It's going to be a half of the red triangle because it's got the same perpendicular height, but it's got a base that is half of the red triangle. And we're nearly there now, because that means half of the square is 6A, the red plus the green, which means the remaining part that I haven't shaded, which I'm now going to shade in purple, this must be 5A. Okay, because it must be that these two add up to 6A, since these two added up to 6A. So the ratio of area P to Q is going to be 5A to 2A, which becomes, oh, sorry, it was P to, got the wrong way around. P to Q is going to be 2A to 5A, which simplifies to 2 to 5. It's not obvious. I think, once you get going, I think it's okay to understand. I think that getting a 2A is probably the hardest bit. On to method 2. Quite pleased with this one. So what I decided to do actually was think about this as a kind of a graph problem. In fact, I said that this is going to be the origin 0, 0, and then this up here is going to be the point 1, 1. And I focused on trying to find the point of intersection between the two lines. So I'm going to focus on, I think, this line to start with. This is going to be 0, 1, and therefore the y-intercept is going to be 1, and I'm going along 1 and down 1, So my equation of my line from top left to bottom right is 1 minus x. Because the y-intercept is 1, the gradient is minus 1. Y equals mx plus c. Y equals minus x plus 1, or 1 minus x. Brilliant. This one here, the y-intercept is now 0. The gradient's going to be a half because I'm going along 1 and up a half. Remember, this is the midpoint. This distance is a half. 0, a half. Therefore, y is a half x. And if I want to find where they intersect, I can simply set them equal. A half x equals 1 minus x. That means 3 over 2x is equal to 1. X is 2/3. And then y is a half of x at that point, or 1 minus x. In both cases, we get y is 1/3. So the area of P, remember, it's okay to do this because we're interested in the ratio between them. We're not like, I could enlarge this, I'd still get the same ratio, the comparison between them. The area of P is going to be a half times the base times the height. I'll just leave it as a half times a third for the moment. And then the area, okay, I need to think about this. I can't find the area of Q directly because it's a quadrilateral, but I can find the area of, let's find the area of the purple region. So this is going to be a half times, now I'm going to say that the base is this part, so it's a half times a half. And then the perpendicular height is going to be this length. Now, x was 2/3, but that was this, which means that the length on the right is 1/3. And then half of the square is going to be just a half, because the whole thing is a 1 by 1 square. And therefore the area of Q is going to be a half minus, okay, I do need to work this out now. So this is 1/12. So a half minus 1/12. So I'm saying I've got half of a square. That's the whole bit here. I'm minusing the purple area. That's going to give me the area of Q. It's going to be a half minus a 12. It'll be 5/12. And over here, I had 1/6 or 2/12. And basically there. So the area of P is 2/12. The area of Q is 5/12. The ratio of P to Q is 2/12 to 5/12, which becomes 2 to 5, which is what we found above as well. Okay, really, yeah, nice question, I think. Different ways to do it. Hopefully both of those make sense. Well done on your efforts on this challenge. Brilliant.